And now to question number 2. Which of the following scenarios represents the smallest percent change? I have a baby that weighed 6 1/4 pounds at birth. Now he weighs 8 pounds, so it's an increase. A painting that was originally purchased for $650 now has a value of $875. Again, that's an increase. The sale price of a new computer is $599. It was originally priced for $700. That's a decrease. And after 3 months of working out, a woman that previously weighed 163 pounds now weighs 150 pounds. That's also a decrease. Now, okay, it's easy to see what the smallest change is. That'd be the F. The baby only gains a pound, 3/4. But we want the smallest percent change. We have to take into account the number that it started out with. So I just verbally did my upsie, right? I want to find the smallest percent change, and see if I can put that on the screen there. Smallest percent change. Okay, so even though it may change by a little bit, the question is, does it change by a little bit compared to what you started out with? Okay. A strategy I'm going to use. I'm going to go ahead and use my the bar model. Okay, so with the bar model, remember this. The bar model, we're going to draw a bar using my graph paper that we're given on the star. And I'm going to draw, since we're dealing with percent, I'm going to draw a bar that is 10 squares long. All right, so, and I'm going to label it. Okay, so this right here is the baby's weight. Okay, so the baby started out always with 10 squares. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, that's my baby's weight. And it now weighs 8 pounds. Okay, so it's increased. So my bar is going to go longer. It's going to get longer. Okay, so I'm going to draw my bar right underneath it. My question is, how many squares did it gain in length? All right, and this is why I made this 10 squares long, because it's easy to find 1/10 of a bar is 10%. Okay, so I can find, okay, let's see, 10 bars is 100%, right? 100% is 6 1/4, or 6.25, right? So how much is just 1 bar? How much is 10%? Okay, this is very similar to the table we made last time. Well, that would be shifting my decimal place over 1, so 0.625. Okay, so every time that baby gains or loses a weight of 0.625 pounds, they just gained or lost 10% of their birth weight. Okay, so my question now is, my baby's going to end up weighing 8 pounds, right? That's my target number, 8 pounds. How many times do I have to add this number right here to my birth weight in order to get to 8 pounds? Well, let's see. I need to gain 8 minus 6.25. All right, that baby gained 1.75 pounds. So I'm going to look here. How many times does 6 go into 17? All right, that's an estimate. I'm using another strategy here, estimating. It goes in, it can be a little bit less than twice. Okay, so a little bit more than twice, sorry, between 2 and 3 times, right? So I'm going to go ahead and draw my percent change as a bar with 2.5 more boxes. Okay, so this is the baby's initial weight. The baby used to weigh 6.25 pounds. Now the baby weighs 8 pounds. And that's what the drawing looks like. 6.25 pounds, 8 pounds. Okay, and this is the percent change. About 25%. Okay, let's try another one. The painting. Okay, so my painting originally had a value of, I'm going to draw 10 squares. Okay, originally had a value of 650. Okay, 100% of 650 is 650. 10% is 65. Okay, so 10% of this, each square here is $65. And it ends up being $875. Okay, so it ends up at being 875. That's my magic number. So I need to figure out how many times do you have to add 65 to 650 before you get 875. Okay. Well, what's my difference here? What's my difference? It's going to be 875 minus 650, which is 225. Okay. So I need to get to 225. That's my, oops, I put too many twos there. All right. I'm not sure my eraser will work on this pencil. There it goes. Okay. So my magic target number is 225. How many times is 65? Go into 225. Okay, so again, I'm going to use some mental estimation here. I know that 60 would go into that 3 times, 70 go in 3 times, so it's got to be more than 3. Okay, it's going to be somewhere between 3 and 4. All right, so my second one's going to be somewhere between 3 and 4 squares bigger. Okay, so I could draw that like that. That is the that's the $875. And my percent increase is somewhere around 35%. Okay, let's try the next one. The computer, all right, it started out $700. I'm going to write a $700 computer that is how many squares long? 10 squares, all right? And each of those squares is 10% of 700, which is 70. Okay. My computer ends up selling for $599. And I want to know how small that bar is going to be. This one's getting smaller, right, because it's a decrease. Well, let's see. How much different is 700 than 599? That is a difference of $101. That's how much you're saving. So my target is 101. How many times does 70 go into 101? Well, it definitely goes in one time. It doesn't go in twice. It'd be 140. Some say 1.5. I'm going to guess at 1.5. All right. So I'm going to draw this 1.5 times 1.5 squares shorter. All right. And my percent decrease is about 15%. All right. Last one. After 3 months of working out, a woman who weighed 163 pounds. Well, guess how long that bar is going to be? Okay. Who weighed 163 pounds. And let's see, 10% of that is 16.3, right? You just write the same number, but you move the decimal over one. And my target is she's going to weigh 150 at the end, which is a difference of 13 pounds. So my target is 13. Well, wait a minute. 10% is actually bigger than 13. Right? So she's already lost. She's lost less than 10%, hasn't she? She's lost less than 10% of her weight. So this one's not even going to be an entire square. It's going to be something like that. I'm going to guess like 8% maybe. I don't know. I'll have to be exact with this because I need to know which one's the least, which one's the smallest percent increase or decrease. Well, that one's about 25, 35, 15, and 8. So my answer is going to be choice J. Okay? Very good. And that makes sense because she didn't really lose that much weight compared with how much she started out with. These other sales, this really gained quite a bit of value. This lost quite a bit, right? Even this baby, he only started out that small. When he gets a pound and a half, let me tell you from experience, that's a huge baby compared to what he was born at. All right. Okay, we're going to take a break here until we get into question number 3.